Behind the technological spectacle and national pride lies an uncomfortable reality that NASA rarely highlights. The return to the moon is being built on unstable ground. The sudden urgency to launch Artemis 2 hides deep contradictions that lead many experts to question whether we are truly ready or merely racing against an invisible clock. The SLS rocket, while the most powerful ever built, carries the weight of a development that has dragged on since 2011, marked by cancellations of previous programs and budgets that exploded beyond any initial forecast. The use of RS-25 engines, the same ones that powered the old space shuttles, is presented as an efficiency choice, but for critics, it reveals a reliance on past technologies to try and conquer the future. This mission is a litmus test not only for the Orion capsule, but for the very financial sustainability of a project that consumes billions of dollars, while agencies face political pressure to justify every penny spent in the vacuum of space. While the public celebrates the high-definition photos, engineers grapple with the fact that this 98-meter-tall giant is, in many respects, a jigsaw puzzle of expensive and dangerous parts. The colossal cost of each space launch system launch raises questions about how many times we can repeat this feat before the budget collapses. Unlike the Apollo era, where funding seemed limited by the Cold War, current space exploration must compete with urgent terrestrial demands. Orion, described as the safeguard of the crew, is a new and complex vehicle, and any minor failure in its deep space life support systems could turn the celebration into an unprecedented tragedy. We are sending 4 human beings into an environment where rescue is impossible, using a system that has yet to prove that it is not just an expensive monument to governmental persistence, but a viable tool for long-term survival. The program's greatest contradiction lies in the impossible balance between the maximum security required for human lives and the resource savings demanded by Congress. Many wonder why, with so much technological advancement, the cost of returning to the moon seems exponentially higher than it was in the 1960s. The truth is that the infrastructure needed to sustain a permanent presence, such as the future Lunar Gateway station, requires an investment that NASA is still struggling to secure. The cryogenic intermediate propulsion system and solid fuel thrusters are robust technologies, but their manufacture involves companies spread across all American states, transforming the engineering into a logistical and political operation as complex as orbital mechanics itself. But what if the real risk isn't financial, but rather our technical inability to deal with the unpredictable that awaits us on the hidden side? Many questions from the public focus on survival. If the main engine fails after the Translunar Injection burn, is there a realistic plan? The technical answer is a free return trajectory, but it depends on a precision that allows no errors. Another recurring question is about protection against intense solar radiation, something that Orion promises to solve with advanced shielding, but which has never been tested on humans for such a prolonged period outside the protection of Earth's magnetic field. Human fragility is the weakest link in a chain made of steel and fuel. The silence of 45 minutes behind the moon is not just a communication barrier, it's a reminder of our absolute technical solitude. During this interval, the crew will be entirely on their own, without contact with Houston, depending on automated systems that, if they fail, have no immediate backup on Earth. This extreme isolation is what differentiates Artemis 2 from any mission to the International Space Station. There, the danger is real, but the proximity to the planet offers a psychological and technical comfort that disappears completely when crossing the boundary of deep space. The technology we are evaluating today is the same that will take us to Mars, but the price of this validation may be higher than we are willing to admit. However, the technical anomalies and astronomical costs may only be the tip of the iceberg of something far more disturbing that has been detected on the lunar surface. Less publicized files suggest that the cameras from the previous mission captured phenomena that official science has not yet been able to satisfactorily explain. Between sensor malfunctions and unexplained lights in deep craters, the question that lingers in the corridors of the agencies is whether we are returning to the moon by our own choice, or whether we were drawn there by something that has finally decided to reveal itself. The tension between what we know and what is being withheld from us creates an atmosphere of somber anticipation for the crew's return. The delivery of this mission phase focuses on validating Orion's life support system under conditions of maximum stress. Astronauts Reed, Victor, Christina, and Jeremy are not just piloting. They are guinea pigs in a system that needs to manage brutal thermal extremes. where one side of the capsule fries under the constant sun and the other freezes in the absolute zero of a vacuum. The success in managing these variables for 10 days will determine whether humanity has a future beyond Earth or whether we remain confined to our low orbit for another half-century. Do you believe the risks of this mission justify the billion-dollar investment, or should we focus our resources on problems here on Earth before attempting to conquer the void? Share your thoughts below and subscribe so you don't miss the reveal of what's really being planned for the lunar surface. Community participation is essential for understanding how the public perceives this new space race. Many argue that the technological advancements generated by these missions return to society in the form of medical and materials innovations, while others see it merely as a display of power without immediate practical purpose. This debate is necessary because the decisions made today shape the economy and science of future generations. The journey to the moon is a road paved with good intentions and risks that no one dares to admit aloud. As the crew prepares for the final impact on the ocean at the end of the 10 days, the real analysis mission will begin. Every piece of data collected, every heartbeat recorded, and every visual anomaly will be dissected to ensure that the next stage, the crewed landing of Artemis 3, is not a disaster. But the sustainability of the program still depends on a question that no one has answered: how to maintain this pace if the cost of each launch continues to rise. The answer to this financial and technical enigma may lie in synthesizing everything we have learned so far, revealing how NASA plans to transform these obstacles into the key to permanent survival. But before we understand how these paradoxes will be resolved, we need to look at the ingenious solutions being tested now, midway through the journey, to prevent Artemis 2 from being the last time we see humans so far from home. The next step in our journey will show how failure is not an option, but a design tool.